I'm Greg Garbos of Four Season Tools. We're continuing to install the benchtop radiant heating system at City Bitty Farm and the headquarters of Four Season Tools in Kansas City. What we have now is basically a lot of the components ready to get fully installed, and it's an opportunity to look at how this layout works. Right here we're going to start with the supply side like we did before. This comes from the hot water side of the hot water heater. We come down, we have the ability to look at the temperature on the supply side, get hot water out of the system. We've got a check valve to make sure everything goes in the right direction. And then we also have the ability to add compressed air into the system to purge all of the water. The check valve is right next to the compressed air. That way when we put compressed air in, it forces the air down the system. So when we're purging the system with air, we can open this valve up, put air in, and all the water will come out of this valve. Then we come down, we've got our union, so that this is an entire module. As I said, we send these parts that are not glued together so you can mess with your configurations however you did. For us, we had more room by actually putting an elbow on the top and on the bottom, and therefore having the unions not in the vertical part of the supply line. We then come into the air scoop module. Again, we've got two different unions here. We've always made sure that all of our unions are facing in the same direction, in the direction of the flow. That way, if for whatever reason we ever needed to connect our supply module to our pumping module, taking the air scoop module out, we have the ability to do that. After that, we go into the pumping portion. This pumping module, as I described earlier, is a redundant pumping system. We've got two different taco pumps. We've got them all wired together, and we'll have a switch right here so we can easily switch between one pump and the other. We've also got two valves, so one of these will always be closed, and that way if we need to switch between the two different pumps, we can switch from one pump to the other pump, open one valve and close the other valve, and then we're ready to go. We decided to use the configuration here, which pushes it underneath our bench so that these pumps are basically out of the way. We're going to use this as our primary pump. That way the flow is directly in line, and our backup pump will allow us to use the back side of that loop. After we come through there, we've got another union. This allows us to service the entire pumping module as a piece if we need to. And then we come in and we have shutoff valves for both the supply and the return side. We're color coding all of our valves so it's really obvious which side is the supply and which side is the return. I did not want to use blue valves for the return side because I don't want the false thought that this is actually cold water. So if we have water coming out of the hot water heater, let's say like 140 degrees, by the time it gets back to the water heater, let's say it's at 125 degrees, it's still hot water, just not as hot as it is coming out of the supply side. So that we can close off this entire system and just test our mechanical parts. What we did is we put in two T's and then a valve in between these two parts. My intention is to paint half this valve red and half this valve black to basically prove the point that this is connecting the supply and the return side. So if I just want to test all this stuff within the system, I can close these two valves right here, open the valve up that connects the supply and the return, and that allows me just to go ahead and circulate the water just inside of these mechanical components. So for the most part, this valve will actually be closed, closing off the supply and the return side, and then as we're going through, we have basically our supply module and our return module. Our first zone is going to be this bench that I'm standing right next to. So as soon as we come out of the supply side, we immediately tee off and have the ability to come up with this red valve, and this is going to be the supply side of this bench. On the return side, we talked about having a reverse return loop. We can't just tee right off of our return side and come up to this bench. We need to make sure is that this is the bench that's getting the hot water first, therefore it needs to be the last bench that we get the return from. So on our return side, this return side is coming, and it's going in, and it's going to the other zones in the rest of the greenhouse. After it's gone through all the other zones, it'll come back, and the last return comes back in this direction and will go up to do this bench. So this return, even though it's coming right out of here, is going to go through the rest of the zones, then it's going to come back, and then it's going to dead end at the first zone that we started at. So the return side dead end, if we start thinking about it starting in that direction, will go through the rest of the system and then come back. So the return is coming in this direction, coming into this. We went ahead and put a couple little elbows in here just so that our heights don't conflict with each other. The return side comes back, does not interact with the pumping module, does not interact with the air scoop module. It comes in and then it goes right into the return module. So this is on the return side. This comes up. We have the ability to put water into the system right here on the return side and then immediately filter the water in the system. And since it's an inline filter, this is also filtering everything that's been inside of the system. So if there's any algae that's building up over time, this filter will be able to catch that stuff. This simply unthreads, allows you to clean out the filter, which is really nice. Then we come up and we have our return temperature, so we can quickly and easily look at the difference between our supply temperature and our return temperature. And then right next to that we have our return pressure. As I mentioned earlier, we want the return pressure kind of the complete opposite side of the pump so that we know exactly what pressure is coming back all the way before it goes back into our hot water source. So this comes up, this tees off, this is where our pressure switch will be, which will run the system. And this is really nice because we can look at our pressure, our return temperature, and our supply temperature right next to each other. Then it's going to go back underneath to our electric hot water heater. Again, there are very different sources for getting hot water. In this case, we are using an electric hot water heater. You can see it here. We've gone ahead and set it down as low as we can so that none of the stuff that's up top is going to interfere beneath our benches. So we've got our 220 volts going up inside of the shop where we have it located. Ran it all in conduit because this is a water-based unit, so we want to make sure that we're keeping our electricity and our water totally separated. We have the hot side, or the supply side, of the hot water heater, and the return side, in this case are noted red and blue. We also replaced the pressure valve with a 30 psi valve, and we have to make sure that we still have the ability to open up that pressure release valve to get that pressure out if we ever need to. So this will do it by itself. If we ever need to relieve pressure, we can go ahead by tipping that up. The other thing to be aware of is on the pressure valve, we have some connections that allow the water to go out and down, so that if the pressure release valve does need to open, that it's not spraying hot water right out here. We want to control where that goes. We're at a great place right now. The next thing we're going to do is hook the rest of this up, get it all wired, and make sure that we can actually test our entire mechanical components within this little area right here before we get any of the benches or the actual radiant lines involved.